6.3, Proving Identities. Keys to identities. I don't know. Really, the keys to identities is practice, keeping a calm mind about yourself, try to visualize patterns, and take a chance. Really, what we're going to be doing is a lot of guesswork, a lot of intuition, but mostly a lot of practice. So let's get started on proving identities. The following is not a trigonometric identity. Sine theta is equal to cosine theta. So verify there exists a theta such that sine theta is equal to cosine theta. So does there exist an angle where the sine value and the cosine value are the same? And I am just going to say, before I get started, sure, consider theta is equal to 45 degrees. So if theta is equal to 45 degrees, sine of 45 is equal to the cosine of 45 degrees because they both simplify to 1 over root 2. However, this is true for one example, but it's not a trigonometric identity. A trigonometric identity proves that it is true for all angles. What I would like you to do is I would like you to use technology to demonstrate there exists in radians an x such that the sine x minus cosine x is equal to tan x. I'll leave this as an exercise for yourself. All right. This is a trigonometric identity. In contrast to the above, in which we were looking for a specific angle where one side of the equation is equal to the other side of the equation, a trigonometric identity is something that is true for all values of theta. So normally, I'm just going to put restrictions here. I don't want to, so you have to include restrictions whenever necessary. That's not going to be the goal of today. The goal of today is just to prove the left-hand side and the right-hand side are equal. Now, when we're doing trigonometric identities, the style that we follow is we say the left-hand side is equal to tan x. The right-hand side is equal to what we must do is we must treat the left-hand side and the right-hand side as two separate expressions. And after manipulating these expressions, if they are equal at the bottom, we can conclude that our statement is a trigonometric identity. So, what is a key? I think a key is to try to break down each expression into its building blocks, which is sine and cosine. So tangent theta, or tangent x, I'm going to write the left-hand side is equal to the cosine, sorry, that's incorrect. Tan x is equal to the sine of x over the cosine of x. Wow, that was actually quite simple. That's the basic building blocks of tan x. Now, 1 minus cosine of 2x divided by sine 2x, I am just going to take here, I'm going to call this the right-hand side. I'm going to put equals. 1 minus cos 2x, now I'm going to look for an identity that can definitely help me out. So I notice that there's a double angle identity for cosine, so 1 minus the double angle identity for cosec. I'm going to choose to write it as 1 minus 2 sine squared x. Now, the trigonometric identity, now is that what I want to use? There's so many to choose from. I'll stick with it, okay? I'm sorry I'm taking so long here, but there is a lot of trial and error. So that is how I can look at the numerator.